PIB number 2 improvement of the shoulder pivot joints hopefully final. It's about these two swivel joints and the servos address number 30 and number 40. To the weight of the arm, the shoulder bends and narrows the inner joint space, resulting in increased friction. Stage 1 shoulder printed from CF filament and installed. It looks better than I first thought. But after just 2 weeks, the problem started again. The graph clearly shows that the two shoulder servos, red and blue, get significantly hotter than the elbow servo, even though the servos don't have to compensate directly the weight of the arms. The old problem persisted. CF filament was expensive and didn't meet my expectations. Stage 2 shoulder reinforced with 8 by 8 mm metal rods. Some adjustments had to be made, and the neck cover is now magnetically secured. This also makes it easier to replace the robot heads without additional tools. This measure is already showing positive results, but the servos of the shoulder joints were still significantly warmer than, for example, the elbows, even when torquing at idle. Stage 3, double swivel bearing. I call it sandwich bearing shoulder. A little CAD work was necessary to extend the bearing guide by 6 mm. Isn't that a sandwich? This measure has finally brought the shoulder pivot to a new level, both in terms of friction and guidance. Now, just a small bearing cover, and the plastic surfaces can no longer touch each other. Stage 3 finally produced the desired result. Servos number 30 and number 40 are no longer thermally noticeable, another step toward a more robust robot. Incidentally, the robot now automatically monitors its servos thermally via a continuous running subtask and actively reports when something gets too hot or automatically initiates relaxation movements. Cool, right? After more than 50 hours of operation, it now looks as if the problem has been solved. Perhaps simply increasing the gap between the plastic parts would have been sufficient. However, the double bearings make a very solid impression,